Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahrin bin Suhaimi. I'm from J4EM 110-4A. I am a group of N4, and today I will make a video about experiment F3, which is impact of jet. Okay, the objective for this experiment is to measure the reaction force produced by the impact of the jet of water onto various target veins surface, and then to investigate and determine the force required to keep a target at a datum level while it is subjected to impact of water jet. And the last one is to compare and analyze the experimental result with theoretical calculated value. Okay, we go to the next. For the apparatus, we have some of the equipment that we use. The first one is pointer. Here the pointer, and the second one spring tension adjuster here. After that we have wing nut, and then we have an interchangeable target. After that we have brass weight here, and then we have weight carrier. This is the place where we will put the brass weight in the top of here, and we have weight platform to support the brass weight surface, and then we have spring. Next we have interchangeable nozzle here, and the last one is water inlet. Okay, we done with the apparatus. We go to the procedure. Okay, now we will go to the procedure, but before we start the experiment we need to make sure that we wear a proper attire, such as we wear a lab coat. If our hair is long, we need to tie it up and tidy it to make sure that we are comfortable during the experiment that working. Okay, for the first one, we need to unscrew the screw nut and screw the wing nut if we want to open the weight platform. After we done open the weight platform, the 5mm nozzle is attached onto the bottom of vertical shaft, and the hemisphere target vane on the top of vertical shaft. After that, we need to close back the weight platform with the vice versa of the procedure one, which is we need to unscrew the wing nut and screw the screw nut. After the process is done, we need to position the weight carrier on the weight platform. We need to adjust it, and we need to adjust the spring tension adjuster to make sure that the distance between the nozzle and the target vane is 20 mm or 0.02 meter. And the way that we need to make sure it by pressing the spring until the target vane touch the nozzle. After we done with the procedure 5, we will move the pointer so that the pointer is aligned to the weight platform, and then we release the spring slowly and carefully and adjust the spring tension adjuster. This process is to make sure the distance between the weight platform and the pointer is estimatedly 20 mm. And then the value of 20 mm will be recorded as a H. Alright, then after we done with the procedure 7, we move the pointer so the pointer is aligned to the weight platform that is floating in the mid position. Okay, and we done. We go to the side of the table. We need to turn on the pump, and the pump will establish the water flow by steadily opening the bench control valve until it fully open. Okay, the target vane will now is defected by the impact of the jet, so we will put the weight onto the weight carrier one by one until the weight platform is again floating in the mid position. So we will put it, we will not, don't put the weight is all in the bundle size, but we must put it one by one, so there will be no any errors that can be disturb the result. Okay. After we done put the measurement, the weight, we go to the pump site before and measure and record the flow rate. After that, we together with the corresponding value of weight on the weight carrier, we need to observe the form of the deflected jet, and we need to check and note the shape. After after we done record the flow rate and everything, we need to reduce the weight on the weight carrier instead, and we still need to maintain the balance of the weight platform by regulating the flow rate for a few steps. Each time recording the value of flow rate and weight on the weight carrier. So when we done with the first week, after we done with first week, we already get the data. We need to reduce the weight, and we need to record again the new data. And then after we done with the all process, we need to close the control valve, and we need to switch off the pump. And after that, we need to repeat the experiment with a different target variance and nozzle. Okay, now I will do the sample calculation for experiment F3, impact of WATERJET, and the sample data that I take is sample data set 1, and let's we go to the calculation. Okay. Okay, and the sample data 1, that the information given is average time, the height, the mass, and area, and what we need to find is the flow rate Q, and the nozzle velocity Vn, impact velocity Vi, the theoretical force Fn, experimental force F, and the error. Okay, the first one, we need to find the flow rate. For the equation for the flow rate is Q equal to M over T, or we can choose the V over T. So the value of V is 0.006. We divide with the average time, which is 23.48, and we use the calculator to find the answer. I'm sorry, there's a miscalculation, which this is not 0.06 but 0.004. We divide with 23.48. Okay, let's calculate again, and we will get the answer of 1.704 power of -4, and the unit is m square per second. and the V here is the volume, so this m cube per second. Okay. Next, we will find the nozzle velocity, which is Vn. For the Vn, the equation that we use is Q over A. We just need to put the information that we already get from the above, and we put in this equation, and we will divide the Q and A. So 1.704 times power of -4, we divide with the A, 1.963. And we will get 8.678 meter per second. Okay, now we will find the number 3, which is impact velocity. And the equation that we use is Vi square equal to Vn, which is the nozzle velocity, Vn square minus with 2 GH, and the G here is the gravity, which is 9.81, and the H that we use is 0.02 meter, and we just put the information that we have, and we will get the Vi. Mm, 74.91. Okay, so here we get the 74.92. And the 2 we get here because we round off the 1, because the next one is 5 and it's more, so we need to round off it. And just we complete the equation, and we get the answer of Vi. And we get 8.66 meter per second. Okay, now we can find the theoretical force, which is Fn, and the equation is Fn equal to mg, and we just put the value of m, which is 0.25 kg, we times with gravity 9.81, and we calculate, and we get the answer 2.45 Newton. Okay, after we done with the theoretical, now we need to find the experimental force, which is F equal to rho QVI, we times with 1 minus cos theta. Because the data that I choose is the impact on hemisphere, so we impact on hemisphere. So the theta here is 180 degree, and we know that cos 180 degree equal to -1, and we put this -1 into the bracket here, and we'll get F equal to rho QVI in bracket 1 minus -1. Okay, and from here we will get the rho QVI. Negative we get positive, so 1 plus 1 is 2. And okay, we done. We already have Q and VI. And for the density here, rho is water, so the density is 1000. So we just put everything in this equation and we'll get the experimental force. So F equal to 1000. Q we take here 1.7, 1.704, negative power of negative 4. When we put VI here 8.66 and we put 2, so the final answer we get here is and we get is here 2.95 Newton. 2.95 Newton. Okay, now we already get the theoretical and experimental, so we need to find the error for the theoretical and experimental, and here we will do the error calculation. So error is the question is experimental, we minus with theory, divide with theory, we times with 100%. So we just need to put the value here and we will get the final answer for the error. Okay. Okay, first we put 2.95 minus the theory is 2.45, divide with theory again 2.45 with multiple with 100%. Okay, so we get the answer 2.95. So the final answer we get here is 20.41%. Okay, so we have done with the calculation, and let's we continue with the conclusion and the graph everything. Okay, so in conclusion, we get all the result needed to fill the table. Based on the result, we can conclude that the impact of water jet on 180-degree plane target is producing a bigger force than a theoretical. Okay, so in conclusion, we get all the result needed to fill the table. Based on the result, we can conclude that the impact of WaterJet on 180-degree plane target is producing a bigger force than a theoretical.